Hello, everybody. All right, so what we're going to do is we're going to do section 2.4, which is more on slope. So in 2.3, we introduce slope and look at it in all types of lines and by itself and everything else. So now what we're going to talk about is parallel and perpendicular lines. Then we're going to interpret the slope as a rate of change, and then we're going to find a function's average rate of change. So mind you, this is all about slope, so keep that in mind as we go forward because everything is going to be in terms of slope. So when we talk about slope, parallel and perpendicular lines are two topics that always come up. So let's start with parallel. So parallel lines, if two non-vertical lines are parallel, then they have the same slope. If two distinct non-vertical lines have the same slope, then they're parallel. That's kind of like one of those if-then statements, the if and only if type things that if you've got two non-vertical lines that have the same slope, then they're parallel. So 1 and 2 virtually said the same thing. Number 3 says if you have two distinct vertical lines that both with undefined slopes, then those are going to be parallel. So two vertical lines are parallel, and then two horizontal lines are parallel, and then two lines that have the same slope going in the same directions are also parallel. So when we talk about being parallel, they have the same slope, but they have a different y-intercept, and that's really the big key when we deal with parallel lines. So we want to write an equation of this line, y equals 3x plus 1. Let's try it again. Y equals 3x plus 1, and we want it to go through this specific point of -2, 5. So first off, the slope that I'm going to be using is going to be 3 because that is what's in front of my 3x. So then I'm going to take that 3, and then I'm going to use the point that they gave me, the -2, 5. And then I'm going to use the point slope formula that we learned in our last section, and we're going to put this in y-intercept form. So y minus 5 is equal to 3 because that's the parallel slope line, or parallel slope, of x minus a minus. That makes it a positive 2. So y minus 5 is equal to 3x plus 6. Kick that 5 over. So y is equal to 3x plus 11. And this is our line that is parallel to the 3x plus 1. But that this line specifically here goes through the point -2, 5. Okay? So take the slope that they give you and the point that they give you, put it in point slope form, and go through the steps to get the equivalent equation that they're looking for. So, same type of problem. I want you to pause the video. Find me the line that is parallel to this one that goes through this specific point. Okay? Ready and pause it. All right. Welcome back. So let's see how you did. So we've got y minus 4 is equal to 1/2 x minus a minus is 10. So y minus 4 is equal to 1/2 x plus 5. So y is equal to 1/2 x plus 9. So this is my line that is parallel to the equations that they gave me and goes through that specific point. All right. So let's move on. Let's see here. Let's talk about perpendicular lines. So first off, we know that perpendicular lines always intersect at a 90-degree angle. And so if we have two non-vertical lines that are perpendicular, then the product of their slopes is -1. So what this is saying is this. I have the slope of my original. So the slope of my original times the slope of my perpendicular will always give me a -1, which means that if this is a slope, let's not use M, so use a different letter. If this is a slope of my original, then I'm going to flip it and change the sign on my perpendicular one to get my -1. So that's what it's saying here. Okay. So you want to flip and change the sign, and then you're going to do the same thing as you did with the parallel. Now, the key thing here is that you can have the same y-intercept on a perpendicular line. That's absolutely okay. If they have the same y-intercept, that just means they intersect at the y-intercept. So that's kind of an easy thing to look at. Number 3 is the big one here. So if you have a horizontal line, its perpendicular is the vertical line. So if you have a horizontal line, the only thing that's going to be perpendicular to that will be the vertical line. Okay? Let's take a look here. I have this equation. I want to know, find the slope of any line that is perpendicular to line whose equation is this piece right here. Okay? So what we're going to do is we're going to go ahead and solve this for y to make our life a little bit simpler. So we get 3y is equal to -x plus 12. And then we've got, we're going to divide by that 3. That's -1/3 x plus 4. So now I want to find the perpendicular. Well, the perpendicular slope, remember perpendicular is an upside down T. And that shouldn't be a Y, it should be an M. My bad. Let's try that again. So that perpendicular slope should be flip it, which is a 3/1, and change the sign. It's going to be positive. Now, it says of any line. So this one didn't give us a specific. It just says of any line. So if that's really the case, then all you're simply going to do is come over here and say, okay, well, fine. Y is equal to 3x plus b. We don't know what the y-intercept is, and it just said of any line, so therefore, that's what we're going to look at. Okay? All right, so this is of a specific point, so we're going to actually just work this one together. So the first thing I'm going to do is identify my perpendicular slope. So my slope here is 2/3, so the perpendicular is going to be flip it and change the sign. So that's the slope I'm going to be working with. They physically gave me a point, so I'm going to say, all right, well, y minus 5. That's equal to -3/2 x minus 6. So we have y minus 5 is equal to -3/2 x plus 18 divided by 2 is 9. I'm going to move this 5 over here, so I get y is equal to -3/2 x plus 14. And this is my perpendicular equation that goes through this point that's perpendicular to this line here. All right, moving right along. So parallel and perpendicular lines, hopefully that was kind of a nice little refresher of what y'all did back. I think you first saw it in geometry, if I'm not mistaken. You might have saw it in algebra. I don't remember. So we're going to look at slope as a rate of change. So slope is defined as the ratio of the change in y to a corresponding change in x, aka delta y over delta x. That means change. It describes how fast y is changing to the respect to x. For a linear function, the slope may be interpreted as the rate of change of the dependent variable per unit change in the independent variable. So these are all different ways that we're going to look at slope as a rate of change. So in this example, we're going to look at how slope can be interpreted as a rate of change. Just remember, when calculating slope in applied problems, keep track of the units in the numerator and the denominator. So you got to look at both the numerator and the denominator. So here we go. In 1990, 9 million adult men in the United States lived alone. In 2008, 14.7 million adult men in the United States lived alone. Use this information to find the slope of the linear function. So we're just looking for slope representing adult men living alone in the United States. Express the slope correct. That's supposed to be correctly, my bad. To 2 decimal places and describe what it represents. Okay? So, what we are looking for is we are going to look for slope here, and we're going to use this information right there. Okay? So now, we have to remember that our slope is our change in y over our change in x. So we have 9 minus 14.7 over 1990 minus 2008. Okay. So what that means, I'm going to come over here to my handy dandy calculator because it's late and I don't feel like mathing tonight. And we're just going to type that in. And then 1990 minus 2008. So that winds up with a negative 5.7 over negative 18. So that's going to be a positive 5.7 over 18. And this is million adult ADULT men over, and it's going to be years. So it wants the slope to 2 correct decimal places. So we're going to take our 5.7 here, and we're going to divide that by 18. And so basically, we get this percentage point here. So it's 0.31, and it's said to 2 decimal places. So 0.32. Million adult men per year. Okay. So our rate of change is 0.32 million adult men per year. So that's what we're looking at. Okay. So all that's asking you to do is find the slope for this. And the key thing for these application problems is your units. You got to make sure that when we talk about this, you have to talk about the correct units. Okay, so let's talk a little bit more about this. We're going to talk about this through the average rate of change because this is the other way that you're going to see it. This is the same exact slope formula you've been dealing with. The only difference now is everything is represented in terms of x. So again, f of x2 minus f of x1 all over x2 minus x1. That is the same thing as saying the change in y over the change in x. So this is just a different way of looking at it. Usually, though, when they have this, that means they're going to give you an equation and they'll give you your x values, and you have to evaluate your y values before you can use this. That's the only difference in this. So find the average rate of change. So here they gave us our function, which I told you they would, and they only gave us our x values. So we need to figure out f of x1 and get an answer, and f of x2 and get an answer. So I take my -2 and I cube it, I get -8. I take my 0 and cube it, I get 0. And so now I put it into my points, or I'm sorry, my slope formula. And this is going to give me the average rate of change over this specific interval. So we go 0 minus a minus all over 0 minus a minus. So that gives me 8 over 2. So that gives me a 4 over 1. So what this is saying that over the interval from -2 to 0 on this function here, I am averaging a rise of 4 and a run of 1 through the whole entire thing. Now, it's not an exact science. Mind you, it's called the average rate of change. So on average, I'm rising 4 and running 1. Okay? So on this specific interval, and we can take a look at this. And so if you pull up your calculator and you throw this into the calculator, and we're only going to focus on, let's go -3 to 1. Not -3, not 0.3. Point, or -3, there it goes. And that looks like it to be, okay, let's change this to 2. Okay. So all this is saying here is that we are rising up 4 and running 1. So if I'm standing here at -2 and I'm coming here to 8, so let's go -2. When I go to my -1, I'm going to rise up 4 and run 1. So on average, so technically if I rise up 4, that's going to give me to a -4 when I run the 1. But watch what happens. That's not a true statement, okay? This is what this is talking about. It says on average, I'm running up. I'm averaging out. So this is taking all those little bitty values and running them all together to give you an average over the course of your interval. And if you think about this, truly think about this. If I go from -2 to 0 and I average that, that's a 1. Okay, so halfway between -2 and 0 is a 1. And so that's what this bottom number here represents. And if I'm sitting down here at -8 and I'm running up to 0, halfway between 0 and 8 is 4. So that's going to give us that. So that's just one of those things that when you're taking a look at this, it's not going to be an exact science, because you can't sit here and be at -2 and say, okay, well, I'm just going to run up 4 and run over 1. That'll give me my next statement. Because if I did that, that would put me at -1, -1, -4. And we know that when we actually type that in, that's not true. Okay. Because if you look at it again, run up 4 and over 1. So if I run up 4 over 1, that should put me at +3, but it puts me at a 0. And this piece right here is the whole reason why it's averaging out as a 4 over 1, because these numbers get really, really, really small. Okay. So average rate of change is just from endpoint, or the end of the interval to the other end of the interval. And you're just going to run the slope between the two and get the average rate of change over that specific interval. So what I want you to do now is I want you to try this problem. So I want you to hit the pause button, and I want you to tell me what's the average rate of change of f of x is equal to 3x squared minus 4x plus 6 on the interval from 5 to 3. So we're going backwards on this one, 5 to 3. Okay, ready, and pause it now. All right, welcome back. Let's see how you did. So if I do this, f of x1 and then f of x2. So I'm going to come over here and I'm going to say, all right, 3x squared minus 4x, oops, not minus, plus 6 Oh, I gotta change my, there we go. All right, and I'm gonna go trace 3. That gives me a 21. And then trace 5. That gives me a 61. So then I've got 21 minus 61 over 3 minus 5. That's negative 40 over negative 2. So that's going to give me a 20 over 1. So my average rate of change is 20 over 1, which is just simply 20. That is my average rate of change over the interval from 5 to 3. Okay. All right. So I hope that wasn't too bad for you. So again, when you're just trying to find the average rate of change, it's just looking at slope at the endpoints of the interval that they give you. So don't think too much on this or whatever else. Same thing when you're running the word problems and application problems, watch your units. You want to make sure that your units are correct as well, because when we deal with average rate of change and application problems, we always need to make sure our units are correct. So with that being said, that concludes more on slope, which is section 2.4. So you need to log into Blackboard and work your problems for 2.4. And I think that is all. So if there's nothing else, I hope everybody has a great night or morning whenever you're deciding to watch this. And I will speak to you soon. TTFN. Ta-ta for now.